Hello, good evening. Today I am going to go to last part of this chapter. So we have done until 1.3 forces in equilibrium already. So the stat paper, of course, I didn't do all. Uh, if I finish it, I might need one more lesson. So this one I leave it to you. You do it, then I mark for you. Alright, some of you pass up already, so I mark for you already. You can see, I mark for you already. Alright. So today we are going to go to 1.4 elasticity, the last part of this chapter. Alright. So now let's start our tuition today. So look at what is 1.4 elasticity. So the definition for elasticity is ability of the object to return its original shape and size, right, after the force applied is removed, right? So okay, so first of all, we look at what is Hooke's law. Hooke's law said that extension of the spring is directly proportional to the force applied onto the spring, provided the elastic limit of the spring it is not exceeded. Okay, so you need to memorize what is Hooke's law. Now, the formula for Hooke's law, it is very easy. F is equal to X, directly proportional. All right, directly proportional to the extension of the string. All right, force is directly proportional to extension. All right, this is the keyword. All right. Of course, elastic limit, I will tell you what is elastic limit later. Now, the graph, it is look like this. Right? F is directly proportional to the X. Okay. Now, the gradient of the graph, it is spring constant. Gradient of the graph is spring constant. Okay. Now, what is spring constant? So, spring constant, it is stiffness of the spring, right? Spring constant, it is stiffness. Okay, how hard is the spring? Okay, now if you go to find area under the graph for F against X, must remember F against X, so you'll find the energy stored in the spring, which is called elastic potential energy. If you find area under the graph, how to find the area under the graph? This is triangle, so area under the graph is here, half time F times X triangle, right? Half Fx. So we know that Hooke's law said that F is equal to X. So the work done, area under the graph is half Fx. So if I substitute the F to here, half F, what is F? Kx. And then X. So that I got half Kx squared. Right, half Kx squared. This is what we have. All right, so this is work done or energy stored in the spring. Now, because of we are going to find the area under the graph, so we are going to plot the graph with F against X by using Hooke's law. But if it is not using area, we don't find area, we don't find the energy. So normally in the paper 3, we are going to plot this way. X here, F here. Alright, so it is also directly proportional, but the area under the graph here, it is not the energy. Right, you need to understand the area here is not energy. Right, not the energy stored in the string. Right, you need to understand this. Now, from here, now we are going to go back to here. So extension of the string is directly proportional to force. Right, go directly. Now, provided the elastic limit of the spring it is not exceeded. So now here, for every string, it has one elastic limit. If you hang an object that more than the elastic limit, the spring will not able to return back to the original shape already. Okay, for example, here, let's say here it is the elastic limit. All right, so until here, more than here, so the string, it is not going to go in a straight line already. What does that mean by it is not going to go to a straight line? For example, you hang 1 Newton, right? You hang 1 Newton, so it extends 2 cm. You hang 2 Newton, it extends 4 cm. You hang 3 Newton, it extends 6 cm. You hang 4 Newton, then it extends like 20 cm, or it extends more or extend less, also can, right? So it is not directly proportional already. Okay, so it loses its elastic limit already. It loses its elasticity already. Okay, that is called elastic limit. So this point here, right, it is called elastic limit. Okay, elastic limit. Now from here, if you do an experiment, so this experiment you gotta do it at school. So I am not going to do with you here. Now here, now you see what is the manipulated variable? Force, right? If manipulated variable, we are going to plot here F, right? So responding variable is the X. So what happened is you set up this experiment, you hang a spring here, and then you got one needle, it point to L, this is L, but before you hang any object, it is point to here. We call it L naught. So you record the L naught first. For example, before you hang any object here, so it is 10 cm. So you hang one lot here, 100 gram. So it will point to 12 cm. L is equal to 12 cm. So 12 minus 10 is L minus L naught. L minus L naught. Right. For example, you got L, it is 27.5. So initially you go and do it, you find it is 25. Right? Initially it is 25. Never mind, I change this number. So 25. And then after you hang 0.05 kg on it, so 50 gram, you hang on it, so you find it is 27.5. 27.5. So you minus it, it is L minus L naught. L minus L naught is your X, extension of the spring. Alright, so you put this number in, and then you got this. So after that, you plot a graph. You find that it is go into a straight line. Okay, it will go into this way. Of course, got some point that is not so accurate. So this is what we have for the experiment. So I'm thinking of, should I do the experiment right now? Yeah. Okay, never mind. We do it together. We do it together. We do one experiment together. So a student carried out an experiment to investigate the relationship between extension of string X and weight of the lot W. The apparatus is set up in 1.1. So now you see it here. Now before you hang anything, right? So 1.2, right? Diagram 1.2. This is 1.2. 1.2 shows L naught, right? Initial length of the spring. So it is 10.0. Remember, you must have one decimal. I told you before. Why? Because a ruler you can read one decimal. Alright. So here, after you hang on something, 1.3 shows you hang 10 Newton. 10 Newton, you go to 12. This is 13, 12.1, 2, 3, 4, 12.4 cm. Okay. And then so on, you put it in, like you hang 20, so it become 14. Right, 14.5, 6, 7, 8, 14.8. Right, 17.2. And then 19.6. And then 22.0. Cannot write 22, have to write 22.0. Okay, this is what we have. Now, what is the manipulated variable? Manipulated variable is, you can read from the graph. Alright, they ask you to do the graph. Now, this question, they ask you x against w. So w is your w is your manipulated variable. Now, what is w? Okay, what is w? So you go and read the question here. The question will tell you what is w. The weight of the lot, comma w. So you just write it in. Manipulated variable, weight of the lot, weight. Right, responding variable. So it's x, right? You read here, right? Plot this one. So this is x, right? Y-axis x. So what is x? You go and read and copy, right? Extension of the string, right? So you read it here. Extension of the offspring. Extension of string, comma x. Just copy only. Okay, now L naught, you put it in. How much is L naught the first time before you put any lot on it? So you find it is 10 cm, 10.0. Put it in. Alright, put it in. So now, then calculate the extension of string by using the equation L minus L naught, right? L0. So which is, you go and calculate here. So you put your data here, right? And then tabulate your data for the value of this. Okay, so you are going to put in the data here. Remember, the left hand side have to put the manipulated variable, right hand side have to put the responding variable. Left hand side is weight. Sorry, no need to write full, just write the symbol Newton. Right, so first one is, you start from 10 Newton, right? 10 Newton. You start from 10 Newton. 10 Newton. You look at the procedure: 10, 20, 30, 40, 50. Yes, you need to write 10.0. Cannot write 10. Right? Ruler 1 decimal. You need to write 10. 10.0. I'm sorry, 10.0. Right? Oh, this one. Oh, you mean cm? Oh, yeah. Most of the time they are giving cm the unit here. Most of the time, right? So if they don't give, you have to write it in. I'm sorry, I didn't put in the cm. I know what you mean already. Thank you. Right? So this is 10, 20, 30, 40, 50. So in SPM, here must be 5 set of reading. In SPM, must be 5 set or more. If you go higher level, it probably need like 6 to 7 set of reading. So in Form 5, standard, right? 5 set of reading. So now, the second thing is, what do we have is, after this, they ask you W, L, and then X. So L. So L is, so the first one it is, we put it in. L is 12.4, 14.8. I remember 2 first. 12.4, 14.8, 17.2, 19.6, 22. I cannot remember. I go 2 by 2. 17.2, 19.6. 17.2, 19.6, and 22. Alright. Make sure the decimal, it is all consistent 1 decimal. Alright. Cannot like some, 22, cikgu, 22 and 22.0, it is the same. So I didn't put. No way. Alright. After L, then you put X. What is X? X is length minus 10. right? Length minus 10. So this is x in cm. So make sure you write the symbol and the unit, right? And unit. So how much is x? So you minus 10, it is 2.4, right? 4.8, 7.2, 9.6, and then 12.0. Now, of course, you ask me, Cikgu, you said after minus need to add in one more decimal. No, I never said that. I never said it. I said you divide, then you need to add in one more decimal. So this one, you are not going to add in one more decimal. So leave it like that. 1, 2, 3. So sometime in the question, they will not give you this way. They will give you, right, L and X only. So they don't put in the W. So you also need to know W must be here, which is this one is manipulated. This one is your responding variable, right? So you put in the data already. Now, you are going to plot the graph, all right? So we are going to plot the graph here. I put it to here first so that it's easier for me to do it. I make it smaller. Okay, now remember this graph don't have negative y-intercept one. So you must start from here, right? You must start from here, and this is the origin, right? This is the origin. So now I plan to do the highest one. It is 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. So if I put here 10, 20, 30, 40, 50, so it will be like too big. Then my last value have to be at here. So very hard for me to plot. So I'll leave it at 10, 20, 30, 40, 50. And then the smallest one is 0. Must be 0, 1. Alright. So higher will be 12. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. June. So your graph will be somewhere like this. So it is more than half, then enough already. Okay. It is must be more than half. Huh? So label your y-axis and x-axis. So this one I know. This is slightly, I need to extend it. So this is your x in cm. So this one will be your W in Newton. So I'm going to plot the first point. All right. So 10. All right. I write the number first. I'm sorry. Yeah. So this is 0, 10, 20, 30, ，OK， so here 1、2、3、4、5、6、7、8、9、10、11、12。This is 12, right? Okay. Okay, I put in everything already. Okay, now I am going to plot the graph right now, so I make it bigger so that easier for me to plot. Now I am going to calculate here. So 1 divided by 10, right? 1 divided by 10, I will get 0.1. Right? I know this one is easy, but sometimes when it is hard, so you need to calculate, right? So I still calculate 1 divided by 10 boxes. So it is 0.1, mean each one is 0.1. Each one is 0.1. I want to plot 2.4. 2.4 divided by 0.1. So I got 24. So I need to go 10, 20, 25 here. 24 is here. So I'm going to plot 24 here. Right? 24. 25 is here. So here is this 24. Right? The first point. The second point is 48. Alright, so for 50 is here, 48 is here. $48 and then 72, right? 71 2. $72 and then 96, 95, 96 is here. So ugly. 96 and then lastly it is 12.0. Right, 12 is here. Okay, so I got everything in already, 50 until here. So now I need to draw a best fit line, right? So best fit line. Right, this number, this one it is too straight, too good, right? So what is best fit line? Okay, I need to tell you a little bit, right? When you draw a best fit line, so when you draw the graph, so I want you like, well, let's say, so this point it is so nice, so let's say, I replot 1, 2, 3, 4, 5. Okay, so this is what we have. So I need to find the best fit line. So this is called a best fit line. So you not necessarily go through every point, but you have to be balanced. All right, balance. So now you see my graph balance or not. I got 1 point. It is at top of the line. 2 point at the top of the line. I cannot 2. Right, I hit 2. 1 at the bottom. So it is still okay. 1 and 2. But these 2, it is at the top, which is quite far. So this one, it is okay, just near. So if can, you put this one further, right? So I adjust a little bit. Okay, now here. Now these 2, it is near right now, right? You hit 1 point and 2 point. Alright, so 1 point and 2 point. So this one is far. So the distance of this point, 1 point, I cannot draw through here. I draw through here, you cannot see. I use freehand to draw. So this distance, it is near. This distance, it is near. So this one is far. Right? At the top, you plus 2 distance here, it is equal to this distance. Okay. So this is called best fit line. Right? So you need to find the best fit line and draw it. Do you get what I mean? Alright, I hope you understand. Alright, so this is what we have. Okay. So after that, they surely ask you to find the gradient of the graph one. So I am going to find the gradient of the graph here. So gradient of the graph is equivalent to, so the gradient of the graph. So I want you to draw a straight line from here. Dotted line or straight line also can. Okay. Now, make sure it is the biggest triangle from the graph, right? Make sure. So it is easier for you. Of course, you can draw a very small one. Right? But you draw bigger one, it is easier for you to calculate. Right? So draw a triangle and then draw this. Alright? Make sure you know this is 90 degrees. Alright? Draw a right angle at here. And then start to calculate. So this is 12 cm. This is 50 Newton. Alright? 12 cm divided by 50 Newton. So this is 12.0 minus 0.0 over, right, 50 minus 0. Okay, so 12 divided by 5, you get so 2.4. Okay, so you get 2.4. 2.4. What is the unit? Have to put in the unit. No unit, no mark one. Right, 12. Right, this is 12 what? 12 what? cm. So this is 50 what? Newton. So per Newton. So you get this. Right, 12 cm, 12 divided by 50. Right, 12 divided by 50. 12, 2.4 cm per Newton. Right, so this is what we have. Wait, go and check this. Sabah 2021. Later we are going to see. Okay. So now calculate the gradient of the graph. So I copy from here. I calculate already. Right. Calculate already. Put it to here. Right. Based on the 1D, state the relationship between X and W. So X is directly proportional to W. Okay. If the string is added parallel into the diagram 1.3, what will happen to the extension of the spring? So decrease. Right. The extension of the string will be decreased. This one I'll explain later. Winnie 帮我接一下，你跟他讲。Okay, so we go to see. We go to see the answer. Paper 3. Do I have paper 3 here? 2021. Wait, I go and see again. What is that? Sabah 2021. Sabah. Yeah. Sabah. Don't have. This one. Oh, no answer. No answer. I don't have answer. So never mind. No answer. So I simply open one to let you see how the question answer. Like for example, I simply take one schema for paper 3. Their schema, it is the same one. Try one. No. Kertas sticker. Okay, for example, this one. We got paper 3. So here we go to see paper 3. Okay. Now, this one it is like you don't care lah. Okay. Now when you menjadual L, I, and V arrow dengan betul, so you have to jadual dengan betul. Now put in L stroke cm. So if you want to write, then write. You don't want to write, it is no need to write one. Like what I told you, no need to write one. Okay, right. If this one is long, then you take a lot of space. So this one have to be 1 decimal because of it is ruler. L length it is ruler. So this one is 0.2, 0.2 consistent, 0.3 1 decimal consistent. So they will say semua nama atau simbol bagi LIVR berserta dengan unit dengan betul. Okay, 1 mark. So semua nilai adalah consistent, mean all 1 decimal. 1 nilai it is consistent. semua nilai LIVR adalah betul. Okay, need to be betul. And then 3 and 4, right? T1, T2, T purata adalah betul. So this one is 1, 2, 3, 4, 4 mark. Now when you do the graph, all right, they will require you to do what? So the paksi have to betul, 1 tick. Right? Unit dengan betul, kedua-dua paksi, 1, 2, and 3. All right. So meaning that what we have is now, do you have this the unit correct? If you got it right, then okay, you got the paksi, you got the unit right, 2 and 3 tick, right? Skala seragam. So what is uniform scale? Uniform scale means 10, 10, 20, 30, 40, 50, or and 2, 4, 6 at 10, all right, have to be seragam, have to be uniform. You cannot 1 and then 3 and then suddenly this one is 0 and then teacher, I start from like 15. Alang-alang one, cannot. Right, 5 titik di plot dengan betul, 4 titik betul is 1 tick. So have to be all tick correct. So you got 2 tick here, 2 tick here. Right, garis lurus seimbang dan licin. Right, so have to be like that. So if they mark 4 to 5 tick, you got 3 mark. 2 to 3 tick, you got 2 mark. 1 tick, 1 mark. So depend on how many tick do you get from the graph. So this one very easy for you to get 3 tick. 3 mark, not 3 tick, 3 marks. So full. So now I mark I mark myself here. So okay. Now this y-axis, okay. Right? X-axis, okay. I make it smaller. Wait. Okay. Y-axis with the unit. Right? Okay. So y-axis 1 tick. X-axis 1 tick. Unit both unit is 1 tick, 1 tick. Okay, 4 tick already. So the uniform scale 1 tick. 5 points correctly plot 2 tick. Right? And then the seimbang, all right, the best fit line 1 tick. Okay, so you want to get 4 to 5 tick, very easy. 1, 2, 3, 4, 5, 6, 7, 8 tick already. Okay. So this is how you get the mark. All right. Now this one I calculate for you already. So this one I will explain later. I'll explain this one later. Now any question before I continue? If not, then I go to factor that affect the stiffness of the string. Okay, so there is 4 factors affect the stiffness of the string: length of the string, diameter of the string, thickness of the string, and then material of the string. Okay, so we look at the first factor. So it is length. So if your spring it is longer, so it is less stiff. Your K it is lower. If your spring it is shorter, right, so it is more stiff. Right, so the K it is higher. The longer the spring, the less stiff the spring. Meaning that if your spring it is long, easy to pull, right? Easy for it to pull. Okay, easy for it to pull, right? Now the second one is diameter of the string. Now this diameter you have to be very careful. So this is the diameter. This one also sometimes they will write it as diameter. I purposely don't want to write it as diameter because I takut you confused. Okay, so diameter of the string mean diameter of the coil, right? This is the diameter. This is the diameter. So this diameter is big, less stiff. Right, this diameter is small, right, more stiff. Small, more stiff. The higher the K. Stiff mean the K is higher. Less stiff mean the K is lower. Okay, the larger the diameter of the spring, the less stiff the spring. Okay, now need to memorize. Now the stiffness of the string, thickness of the string, thickness of the spring also known as diameter of wire. So this is the wire. You see, so thin, right? Diameter. You see this diameter, so big, right? It's so thick. This is thick. So diameter of the wire is big. Not diameter of the string. Don't say diameter of the string. Diameter of string is here. Diameter of wire is this wire. This wire. You go and coin it. This diameter is big. This diameter is big. This diameter is big. Diameter big is more stiff. Right? Diameter small, it is less stiff. Right? The thicker the spring, or the larger the diameter of the wire. Not spring, Don't say diameter of the string, Diameter of string, it is different, Or cross-sectional area. Right? So it is the stiffer the spring. Lastly, it is material of the spring. Material of the spring is if iron, right, it is less stiff, not that hard. If steel, it is more stiff, right, more hard, right. The K will be higher. Okay, so if I plot the graph, right, I plot the graph by this way. From here, so I'll have two graph, 1, 2, right? So I have 1 spring and 2 spring. Now, when we plot the graph, okay, now I repeat one more time. I know just now I told you already, but some of you still not really sure. So this is F, this is X. Teacher, just now you do the experiment, is you plot the graph here, X, and then this one F, because we are doing paper 3, so we do it this way. But if we are not doing experiment, so you plot the graph into this way. You plot the graph into this way. Okay? Because in the graph, this one is your manipulated, this one is your responding. But from here, we are going to see the stiffness, the area under the graph, and so on, because we are applying Hooke's law here. Okay, so you got this. You got this. So this one, the spring, this one it is long or short, right? So this one it is stiff. The gradient it is high, it is stiff. So it is short. How am I going to put wait I put it to here, short. Right? So this one will be long. Wait. This one will be long. The spring long. So long, it is less stiff. Right? So short, the gradient high, more stiff. Of course, if the question come into this way, X and F is this other story. Okay, terbalik. So mean the longer the string, so this one it is stiff. This one is less stiff. Right? So this one it is less stiff. Short it is stiff. This one it is stiff. This one is less stiff. The gradient high, it is more stiff. Teacher, I still don't understand why gradient high it is more stiff. Alright? You see? Now, let's say 1 Newton extend 1 cm. 2 Newton extend 2 cm. 1 Newton extend 1 cm. 2 Newton extend 2. Right? This one, it is like 1 Newton it extend 3. So soft. I hang 1 Newton, it extend a lot. So it is soft. It is not stiff. Right? You need to understand, Okay. Now, if I plot the graph here, so you know. So this one will be the same. For this graph, so this one will be smaller diameter, right? Short and then smaller diameter. and this one is a larger diameter, and this one is thicker. All right, this one is thick. How am I going to put thick? Right, this one is thin. And lastly, this one is steel, this one is iron. 帮我接一下，你跟他好好讲，我现在没有空。Got people call me. Ask my wife to answer. Not free right now. Okay, and so this is 4 factor affect the spring constant. And then here, lastly it is the arrangement of the spring. So if you arrange in series, what happened? All right, so you see, this one is called series. You arrange one spring here and then another spring here. So this one, it will be very soft, very easy to pull, right? Less stiff, right? This one is less stiff, right? So you extend a lot. Later we are going to do in calculation, no worry. Now here, if you arrange the spring in parallel, so the extension of the spring, it is half from the original. Half from the original. So it will become x over 2. This one will become 2x. This one will become half of the x. Alright. Now, just now, they said, this question. So, 你跟他讲我8点半打给他。If a spring is added parallel to the 1.3, what will happen to the extension of the string? You add in one parallel, so the extension will be lesser. Okay. All right. So we are going to see the calculation here. So most important one here, it is calculation. If you can do it, your maths is good, and then you got your maths is good. So this one will be very, very fast and very, very easy for you. You can do it common sensely. All right. If you cannot, then you have to do it step by step. So step by step, it will be slightly longer time to do it. All right. I tell you, how many years ago? Like 16 years ago. 16 years ago, I'm teaching my cousin. My cousin, she is doing pharmacy in UK right now. Right? Her result very good. Her physics very good. Always get A1. Only this part she cannot. Right? She don't understand. No matter how I teach her, she cannot understand. So she is very, very smart. But she cannot. She only can do by using step. So other students, they can like doing 1, 2, this one is how many Newton. They can straight away give the answer, but she cannot. I don't know why. Right? But you can try later. See whether you can do it or not. Okay. Now original length, it is 10. All right. You see, so you hang 1 Newton, it become 12. Mean you add 1 Newton, it plus 2, right? So you add 2 Newton, extend how many? What do you think? You add 1, extend 2. You add 2, extend how many? Some of you can, yeah. Of course, this one is easy. So most of you, I guess, can, right? So plus 4, right? Plus 4. Original is 10 and then plus 4. So it is 14. Am I right? Easy, right? Now you add something, I don't know. Right? But it extend 5. Meaning that this is 2 Newton, 2.5 Newton, right? 2.5 Newton. So this one is easy. Now, how to do it? By using Hooke's law. So I'm going to show you how to use Hooke's law to do it. Number 1. So we apply the formula of Hooke's law. F is equal to Kx. K. So we need to find K first. Alright. From here we need to find K. So F, we put in F first. Right. F is 1 Newton. Is equals to K, I don't know. Extension, it is 2. Right. 2 cm. 2. Right. So it is 1 over 2. 1 divided 2. K, it is 0 0.5. 0 0.5 watt. This is Newton. This one is cm per cm. Right. K is 0 0.5 Newton per cm. So you find K first. Always find K first. After you find K, so this one you put it in. Right. F is equal to X. F. How much is the F? 2 Newton right now. So you are hanging 2 Newton right here. 2 Newton. Right. Is equal to K. K, I got it. 0 0.5. X, I don't have it. So I want to find X. Right. So X is 2 divided by 0 0.5. It is 4. Right. 2 divided by 0.5. It is 4. Right. So you got the extension of 4. So they ask you to find y. So how long is y? Y, it is equivalent to original length plus 4. So answer is equal to 14 cm. Y is equal to 14 cm. So number 2. Number 2. Right. This one should be easy for you. Right. Number 2. So I already got the K. So I don't need to calculate the K, recalculate the K again. No need. So F is X. F is Kx. So F is the weight that I don't know. Right? I don't know. W. K is 0 0.5. Extension is now from 10. Original length is 10. So become 15. So extension is 15 minus 10. So 0 0.5 times 5. 0.5 times 5, it is 2.5. 0.5 times 5, it is 2.5. So we got 2.5 unit Newton. Okay. Now, of course, some of you will ask me, teacher, I still don't really get what is K. K is spring constant. Another word, it is called stiffness of the spring. Now, what does that mean? Meaning that, what is 0 0.5 Newton per cm? 1 cm, you will 0 0.5 Newton, it will extend 1 cm. If you want the spring to extend 1 Newton, it will extend 2 cm. 1.5 Newton, it will extend 3 cm. 2 Newton, it will extend 4 cm. Right? For example here, like 2 Newton, it will extend 4 cm. So this is a ratio. So 0 0.5 Newton per cm. Okay. So of course here it will be 2.5 Newton. It will cause it to extend 5 cm. So here 2.5 Newton. So this one is 2.5 Newton. So this is what we have K, the stiffness of the spring. Now some of the stiffness, it is harder. For example, K, it is equal to 1 Newton per cm. What does that mean? So 1 Newton, then it baru can extend 1 cm. It only can extend 1 cm. Not like this. This one 0 0.5 already extend 1 cm. So let's say this is 2 Newton. So you extend 2 cm. So 2 Newton, this one already get very long, very soft. right? 0.5 very soft. But this one is 1, quite hard compared to the first one. This is called extension of the spring. Extension of the string. Okay. And then extension of the string, how hard, how soft it is, stiffness of the string. So we try to see this kind of question. This kind of question, okay, how to do it. So now original length, I don't know. Okay. But it become 12, right? This is 2.5 Newton. It become 14, 5 Newton. Alright. Now, I want to test you whether you can see it or not. This is 5 Newton. So I reduce 2.5. Right? It minus 2. I repeat. I got 5. 5. I reduce 2.5. So it reduced 2 cm. So this one, 2.5 remove. How many cm is this? How many cm is this? Some of you can see it. Alright, of course the answer is here. Alright. So this one, 2.5 minus 2. 2.5 minus 2. Right. Some people, they can see it. Teacher, this is 10 cm, so easy. But I told you, some people, they cannot see. Then you have to do it step by step. If objective, you can circle the answer directly. Because you can see it. But, right. How to do it? So, we need the first formula. F is equal to X. F is equal to X. F, right, 2.5 Newton is equals to K. K, I don't have it. X, extension of the string. Extension, original is L0. And then it become 12. So it is 12 minus L0. So how many unknown do we have? How many unknown do we have? So we got K, you got L0, cannot do. So leave it as 1. The first equation. So I want to write the second equation. So it is from here. Here to here. Right? So F right now it is 5. K, I don't know. X, extension of string, it is 14 minus L0. Okay, so I got two equation right now. So I'm going to solve the first equation and 2 equation by dividing it. Right? So this one divide by this one divide by this one. So what do we have is, so I use 2 divide by the second equation divide by first equation bigger, easier. Because 5 divided by 2.5 easier. Right? So what we have is, so we got 5 divided by 2.5 is equivalent to, so this equation here, I want to eliminate the K, right? Okay, so K and then 14 minus L0. Okay, here it is, you copy down this one, 2.5 is this one, okay, 12 minus L0. Okay, now as we have K and K, we can cancel, right? So this one I time it up here, this one I time it up here, right? Or you don't want to time it up, so this is 5, this is 2.5, so it become 2. Right? Also can if you want to cut it. So now I better time it, right? Because I takut you're not sure about this one. So I time it up. K I cancel already, K I cancel already. So 12.5 60 is equivalent to 5 times L0 is 5 L0. Negative 5 L0. Okay. This one cancel, cancel. 12 times 5, 60. Negative L naught times here, negative 5 L naught. Alright. So this one 2.5 times 14, it is 35. So okay. 2.5 times L naught is 2.5 L naught. Negative 2.5 L naught. So now L naught and L naught I move together. This one I move to here. 5 minus 2.5. 35 I move to here. Okay. 35 I move to here. Become minus. Right. So here will be right 60 minus 35. So this side will be 5. This is negative, become positive. So 5 minus 2.5 L naught. Okay. 5 minus 2.5 left 2.5. This is so long. Become 25. Right. So 25 divided by 2.5. L naught will be L original will be 10. Right. You see so long. No, not very long. Right. So you need to do some calculation if you cannot. If you can see it directly, go ahead. If cannot, then leave it. Alright, do it this way. Now, if your L is 10 already, you can sub into 1 or 2, up to you. Okay, I sub it into 1. Okay, so 2.5 is equals to K 12 minus L naught. 12 minus L naught. How much is L naught? L naught is 10. Right, so 2.5 divided by 2. Right, 2.5 divided by 2. 2.5 divided by 2, it is 1.25 Newton per cm. That's what we have. That's what we have. Alright. You substitute this one into here or into here also can. Up to you. So sub into 1 or sub into 2 to find another value. Alright. To get the K. Okay. The K is the spring constant. Alright. So I want you to try one question here. I go out to make one phone call. I'll be right back. What I tell you why I am so normally I'm not so rushed to get the call because of this is the electrician. My that day still remember my oh no from 4 class I cancel the class because of my house break out, and then he come to fix for me, and then the things he's not fixing it well, so I need to tell him help me to do it again. So you help me to do this question, right? Find spring constant and then find P. Alright, so I'll be right back. Okay, so let's continue. So, okay, now here spring constant. So they ask you to find spring constant. So now we got a formula. F is Kx. So we put it in. F 0.5. K don't know. X extension. Extension is 10 and 12, right? So now 12 minus 10. So you always use a bigger number minus a smaller number. So don't use 10 minus 12. You get negative extension. So of course you tell me this one extension, it is compression. Compression, it is lesser, right? So no. Don't don't use uh don't use the negative number. Okay? Always use a bigger number minus smaller number. So 0.5 divided 2, it is K, it is 0.125 Newton per cm. No negative number, right? So the first one done already. The second one, they ask you about the P, right? P, how long it is. So F is Kx again, right? Same thing. F is Kx. F is Kx. F, it is right here. It is 1.5. 1.5 Newton. K, it is 0.125. Extension, I don't know, right? So I need to find the extension. So extension will be, so 1.5 divided by 0.125. You get 12 cm. Here. Oh, this one is wrong. 0.25 by Roberto. Okay, my mistake. Here, 0.125. 0.25, not 125. Okay, 0.25. I'm sorry. Sorry. So 1.5 1.5 divided by 0.25. You get it as 6 cm. Now 6 cm is not yet your answer. Now 6 cm is it compressed down 6 cm. So original is 12. So you need to answer P is equals to 12 minus 6, which is 6 cm. This one is your final answer. Okay. This is what we have. Alright. I hope you can understand this. Alright. So we come to do something that is more complicated. Alright. So you got combination of the spring. Here, this one it is arranged in parallel. Right. So the two spring in parallel. So now what you need to do is when you see parallel, right, you time it. Right, the K it is higher, right, stiffer, right, harder to pull down. So K you time, right, you time to get the K. Okay, if you got 2 spring, you time 2, 3 spring, you time 3, 4 spring, you time 4. That is how you get the K. Now, if you got the spring that arranged in series, so you don't need to do anything. You just calculate one by one. Okay, that is how I do it. Right, parallel, the K you time it. Right, time number of spring to get K. Okay, now how? Now I make it simple for you, right? Faster to answer one. All right. Now 1 Newton extend 2, right? So 2 Newton here, 2 Newton extend 4, right? 3 Newton extend 6 cm. Okay, now these two spring together, so harder to pull down, right? So the extension will be lesser. The extension will be lesser. So here you got 2, so you divide it by 2. Teacher, you said time 2 to get the K. Right? This is not the K. So I divide by 2. 2, I divide by 2, it is plus 2. So altogether here is plus 6. Plus 6. So original here is 10. Here 10, 10, 20, 26. You got the answer of 26. How about this? 6 divided by 2, it is plus 3. 6 divided by 3 plus 2. So here extend altogether extend 11. Plus 10, 20, 30 plus 30. So it is 41. You see, you can get the answer very, very quickly. But now I want to do it step by step to show you how to get the answer. Now, first of all, we are going to find K first, right? F is equal to Kx. F, 1 Newton. K, I don't know. X is 2, right? 10 and 12, right? Become 12. 12 minus 10, right? 12 minus 10. So it is K, it is 0.5. 1 divided by 2, it is 0.5 Newton per cm. So I got a K already. Now I want to find this, right? So now F is Kx again. F is Kx again. F now it is 2 Newton. K. Now K is 1 spring. I don't care. So 0.5. X I don't have. So I want to find X. 2 divided by 0.5, it is 4. So for this one, it extends 4. How about this one, right? F is Kx again. F it is 2 Newton. K it is 0.5. Extension of the string, right? I don't know. Extension of the string. But, alright, you need to know, here it is 2 spring together, as I told you, right? You arrange in parallel, you need to multiply by number of spring that you have, your K. So, the K now, I have to time 2. Why I need to time 2? Because parallel, right? So, I show you here, this is time 2 because of 2 spring. Parallel. Right, I make it short. Right, time 2 because 2 spring in arranged in parallel. So 2 divided by 0.5 divide by 2. 2 divided by 0.5 divide by 2. So I will get 2 cm. So extension of the string, it is 2 cm. So X is 2 cm. So altogether will be, here will be extend 4. I calculate here already, 4. Here, 2. So altogether, P will be equivalent to, P is equivalent to original length plus, you got 2 times original length plus 2 plus 4. So altogether is 26. I repeat one more time. So this one, F is Kx to find the spring constant. Now here 4 because of 1 spring first, right? 1 spring. So 1 spring, K is 0.5. 2 spring together, so you time 2, right? Yeah, K you need to time 2. Time 2. So now original length it is 10. You tell me, teacher, this one 10, this one 10, altogether 20. No. This is 10. This plus together is 10. Right? So this total length initially it is 10. So it extend 2 cm. Extend 2 cm. So altogether 26. So number 2, we try to do it. F is Kx. We got it already here. K. So F is Kx. Now here we are going to hang 3 Newton here. K is 0.5 for one spring only. So K is 0.5. So 3 divided by 0.5. So 3 divided by 0.5, it is 6. So X is 6 cm. So for the first one. Now two spring together, you have to arrange the spring in parallel, right? So you time 2. Your K, you need to time 2. So F is Kx. F is 3. K, now it is 0.5. I multiply by 2. Right? Because two string arranged together. Right? So I find X. So 3 divided by 0.5 times 2. Divided by 2. So 3 divided by 0.5 is 6 divided by 2. So you get 3 cm. X is 3 cm. So it extends 3 cm. So F is Kx again. Now 3 spring arranged in parallel, right? K is 0.5, but now how many spring arranged together? 1, 2, 3 spring together. So 3 spring you need to time 3. Right now 3 spring you multiply by 3. Alright, so find the X. So 3 divided by 3 it is 1. 1 divided by 0.5 it is 2. So X will be 2 cm. So altogether, now I want to find Q is equivalent to 10 plus 10 plus 10 plus 6 plus 3 plus 2. So Q going to be 10 plus 10 plus 10 plus 6 plus 3 plus 2. So altogether is 41. So now here, and here, you need to be very, very careful. Here it is 2 spring in parallel. How about this? This is 3 spring in parallel. Okay, so I put it nicer a bit. 3, this one time 2, this one time 3, time 3, time 3, because 3 spring in parallel. So you time 2, time 3. Are you okay with here? Can you understand? Now, if you are not doing this way, like objective way, Cikgu, this one very fast. I repeat one more time. So see whether you can see or not. 1 Newton plus 2. 2 Newton plus 4. Right? Plus 4. So this is 2 spring. Harder to go down. So you divided by 2 the extension. So divide by 2. 4 divided by 2 become 2. So 10, 20, 26. You get the answer 26. Very, very fast. How about this? Right? 1 plus 2. 2 plus 4. 3 plus 6. Plus 6. So this one divided by 2. 6 divided by 2. The extension divided by 2. Right? Because 2 spring together. So divide by 2. So plus 3. This one 6 divided by 1, 2, 3. Plus 2. So altogether is plus 11. 11, 21, 31, 41. So altogether is 41 cm. This way. This is what I told you. Some of you can, then go ahead. Right? Some of you cannot. Hey, Cikgu, I cannot get it. Right? So then you do one by one by using this way, because this one got working. If you're using this way, it is ratio, no working. The problem is no working. Okay. Question from here before I continue. Okay. Question? I hope no. I hope no. So we go to this kind of question. So this kind of question, they ask you to find spring constant. And you have to look at the second question. What do they ask you? Right? Energy stored in the spring. Energy stored in the spring, you cannot use the K as Newton per cm already. If they ask you energy stored in the string, cannot. Because cm is not SI unit. Now, teacher, just now K, you can calculate K by using Newton per cm because they don't ask you energy. They don't ask you energy. They don't. Right? They don't ask you energy. But if they ask you energy, you have to put it in Newton per meter. Now, never mind, I explain to you, see whether you understand or not. Number one. So F is Kx. So F is 5 Newton. K don't know. X is 2 cm. So as I told you, 2 it is in cm. If they don't ask you energy, boleh. But now they ask you energy. So you have to change it to meter. This one have to change it to meter. So 5 times 100, 500. 500 divided by 2, it is 250. K is equals to 250 Newton per meter. Right now, it is Newton per meter, not Newton per cm. But the thing, it is the same. Now, see, I redo. F is Kx. F is 5. K don't know. X is 2 cm. So 5 divided by 2 is K is equal to 2.5 Newton per cm. Meaning that 1 cm it is caused by 2.5 Newton, right? 2.5 Newton per cm. 10 cm it is caused by, you move 1 decimal, 25 Newton. 100 cm it is caused by 250 Newton. Right? 250 Newton will cause you extend 100 cm. Am I right? Okay. 100 cm it is 1 meter. So it is 250 per meter. 250 per meter. They are the same thing. They are the same thing. Exactly the same. But this one, it is in SI unit. This one, it is not in SI unit. Now, of course, just now, if you ask me back, hey teacher, why not we all use SI unit? So now, when you do this kind of question, if you want to use SI unit, it will be a bit long. So if they don't ask you energy, you see, now F is equal to Kx. You see how I do? F like 0.5. K, how much is X? X is 2 cm, 2 over 100. Right? So I change it to Newton per meter. So 0.5 times 100, it is 50. 50 by 2, K is equal to 25 Newton per meter. Right? Now, I want to calculate this. F is equal to Kx. F, 1.5. K is 25. X, I don't know. So, now this one divide. 1.5 divided by 25. 1.5 divided by 25. You will get 0.06. X is equal to 0.06 meter. Now, when you answer, this one how long it is? 0.05. 0.06, I'm sorry. Right, 0.06. But they ask you this one 12 cm, 10 cm, this one P is how many meter? Do you think how many meter? No, right? So you have to change it to cm. X is 6 cm. So P is 12 minus 6, still 6 cm. So it will be a bit long. You need to change it back. So no need. Don't waste your time. Right? Unless they ask you energy. Energy, then you must do it. Right? Okay. Yeah. Like this, energy. So number 2, they ask you the energy store. Energy store in the string is formula half Kx squared. Energy stored in the spring, half kx square. Half kx square. K is 250, right? 250. X, extension of the string. So this one extend 2 cm, right? 2 cm. So we use 2 divided by 100. Okay, 2 divided by 100 must be in meter square. Okay, so now what we have is 0.5. Half is 0.5. Right? I normally use 0.5 times 250 times 0.02 square. So I'll get 0.05 unit. It is in joule. Unit joule. Now remember, this one must be in meter. This one must be Newton per meter. Okay. This one must be in meter when calculate energy. Must be SI unit. SI unit. Okay. Are you okay with here? I hope you are okay. So we quickly go to some question here. Diagram 5 shows an arrangement similar spring W, X, Y, Z and L, lot L, alright, respectively hang below them. So which of the pair of the spring arranged produce the same extension, right? Okay, now 2 spring, you hang 1, right? 3 spring, you hang 3. 2 spring, oh, we haven't do the one with this one. I haven't give you any example. I haven't give you this kind of example. I need to give you one example because of if not later you haven't do. You don't know how to do. Okay, now where I put it into here. Wait I add in one more. I add in one more question. Okay. Example. Extra example. I need to draw on my own. Wait Original length, I don't know. Now, this is one spring. I hang one object here. So, this one will become like okay. This is original length 10 cm. So I hang one object, for example 2 Newton. So it become like 11 cm. Okay. I hang 2 Newton, it will extend 1 cm. Okay. Now how about if I hang it into this way? One spring. Okay, so I hang 5 kg. I hang 5 kg. How much it will be? Find this one. For example, this one is called M. Find M. My question is find M. How long is this M? Not 5 kg, 5 Newton. I'm sorry. What am I doing? Uh, uh. This one how long? Okay. So now, do they ask you find energy? No, right? So no, no. This kind of question, no. So what should I do? Right? F is equal to kx. I'll do both way for you to show you right, how it is work. Now F is 2 Newton. K don't know. X is 1 cm. So K will be equal to 2 Newton per cm. Okay, I repeat. F is 2 Newton. Right? Extend 1 cm. 11 minus 10, 1 cm. So this one not asking you energy, so you no need to change it to meter. Okay. Now you find K. Now if the spring in this way, so I want you to do directly here. F is equal to kx. This is 5 Newton, like what I told you, 5 Newton. K is 2, x don't know. So x is 5 divided 2. So x is 2.5 cm. So it will extend 2.5 cm. So meaning that this one extend 2.5. Meaning that this one will extend 2.5 cm. This one will extend 2.5. So altogether, you will extend 5 cm. Am I right? Okay. So, M will be equivalent to, original is 10 plus 10 plus 2.5 plus 2.5. So answer is 25 cm. Now, of course, maybe some of your teacher will teach you, when you do this, F is kx, you get this, So now you want to find two spring, F is equal to kx. F is 5 Newton. K is 2, but two spring in series, not parallel. Series, not parallel. Series, I repeat. So two spring, you divided by 2, right? So answer is find x. So I cancel. This one is your x. X is 5 cm. So how much is M? M is original length 10 plus original length 10 plus 5. Then you get 25. You get back to the same thing. But normally when my student, they do it this way, they'll get it wrong because they just use 10 plus 5. Right? Because this 5, extension 5, is for two spring together. Two spring together. So they will forget, this one is original 10, cikgu. Why you need to 10 again? So two spring, you have to do it separately. So that's why I do it separately. So this one, two spring in parallel. So I don't care. I just calculate one spring, extend how much. Meaning that what I do is, the thing that I do is, I hang one object at here, 5 Newton. So this one plus 2.5. This one I hang one 5 Newton at here plus 2.5. Altogether, this one is original 10 plus 2.5. 10 plus 2.5. So I get 25. I do it separately. That's why I don't teach you. Teacher, divide by 2. Right? Parallel divide by 2. Series times 2 or not. Actually, yes. But if you do it that way, you will get wrong. Normally, you will get wrong. So I don't encourage you to do it that way. Okay? Do you get what I mean? Do you understand what I want to tell you? If you don't understand, I re-explain. It seems like more complicated. Huh? Okay? Meaning that, alright, never mind, I explain. So K, you get the K already, So F is equal to Kx. Now F 5 Newton. Right? K is 2 Newton, but two spring in series. So you divided by 2. So the extension all together, 1, 2 spring together is extension, it is 5. All together, here to here it is plus 5. I takut here, you said here plus 5. Then here plus 5 plus 10. No. No. Right? Or after you do it, how much is M? You forget to plus. So you better hang one at here, calculate here, extend how many? Here, extend how many? So series, you no need to bother. Just calculate one by one. Like what I do in parallel, also like that. Same. When I calculate parallel, so I calculate I 2 Newton here. This one extend how many? Right? This one is 6, then this one is divide by 2. It is, you can calculate here. Calculate one by one. Calculate one by one. Then you get the answer. Okay? Do you get it? I hope you can get it. Okay. Now come back to here. We do some questions first. Now, diagram 15 shows the arrangement of similar spring W, X, Y, Z, and L respectively hang below them. Right? So you got L, you got 3L, you got L, you got 2L. Now, which of the pair produce the same extension? Okay. Now, if this one is 2 spring, right? This one, 1. Okay. Now, 1 lot. Now, 3 spring, right? 3 lot. Mean, this is 2 strings for 1 lot. Mean, 1 of string is half lot. 1 spring is half lot L. Right? 1 spring is 1 L. Right? This one is series. No need to see. Now, 2 spring is for 2 lot. Right? 2 spring is 2 lot. So, 1 spring, it is 1 L. I do it this way, will be fast. So, this one and this one, X and Z will be the same. X and... no? Repeat one more time. 2 spring, 1 lot. 2 spring, 4 spring. Oh, okay, I'm sorry. Should be W and Z. I see it wrongly. See here, this one is, I do it separately. This is 2 lot, right? So meaning that 1 lot at here, and 1 lot at here. I do it separately. So 1 lot, 2 lot, right? I can separately 1 lot, 2 lot, right? So this one is 1 lot. So W and Z will be the same. W and Z. Answer is B. Now, what's the difference between this one? Teacher, this one 3 for 3. So this 3 for 3, yes. But this one is 2 for 2, right? This is 1, 2, 1, 2 for 2 only, right? It is not like 1 and 2 for 2, right? If 2 for 2, so these 2 will be the same. Is that okay? So answer is B. We continue. Which one is true about the extension PQR? 1 kg, 1 kg, 1 kg. So now this one, if you arrange in series, the extension will be more. So this one, the most one, right? Q, it is extend the most one. So Q is this the highest, so have to be at the back, right? B is the answer. Now this one, it is normal. Second one is P. Lastly, this one hang by 2 spring, so harder to extend. So R is the last one. Answer is B. Continue. Now, diagram 14 shows the force against the X for the spring. The shaded area, it is 0.8 joule. So determine the F to produce a 5 cm of spring constant. And the spring constant. Extension 5. So now what do we have is F is kx squared. F is kx squared. So they said this one is how many joule? They said 0.8 joule. Sorry, I forgot to put in half kx squared. I'm sorry. Half kx squared. So half kx squared. K I don't know. K I don't know yet. Now x is 5 cm. I said 5 cannot. You have to put in 5 divided by 100 because you are calculating energy. Okay, so 0.8 times 200 divided by 5. 0.8 times 200 divided by 5. It is 32 joule per K is Newton per meter. Don't have. One more time. 0.8 times 2 times 100 divided by 5. 32 what? 0.8, yeah? 32. Don't have. Force is 8 Newton. Force I don't know yet. F is to kx. I calculate that. F I don't know. K it is 32. Extension it is 5 over 100. 32 times 5 divided by 100. 1.6. Don't have the answer. No answer this one. Wait something wrong. 2024. I see whether I do anything wrong or not. F. Oh, this is energy, not F. Energy is half kx squared. Yeah, correct. Half k x squared. I forgot to square. Yee. See, one thing wrong, everything wrong. Okay, I redo 0.8 times 2 divided by 0.05 square. This is 0.05 0.05 square. So 640 baru betul. You see, I forgot to square. So 640 is my answer. Alright, so I want to find F already. Now, here, F is kx. F is kx. F I don't know. K 640. X is extension 5 cm. So you need to change it to meter 0.05. Right? 640 times 0.05. 32. So F is equal to 32. This one betul. Okay. So answer is C. Okay. So we continue from here. Diagram 12 shows below shows a spring with original length 250 mm. The spring is compressed and the weight it is 3 kg pressed at the top. What is compression? What is the compression of the string in meter? So what do we do is F is equal to kx. Just two formula. F is kx and energy is half kx squared. So now original length it is 250 mm and then The spring is compressed when the 3 kg put at the top. Okay, 3 kg. 3 kg. Normally, we are going to take the 3 kg is 30 Newton. Right? It's easier for them to calculate. Right? If not, very hard to calculate. Okay? I don't have. Wait, something is missing. Original length is 200. Three kg, 30 Newton. Okay, K don't know. Extension it is. Original is 250. 250 in meter. I divide mm. I divide by 10, 25. I divide 100, 0.25. 0.25 meter. Minus L. Minus this 200 mm. So minus 0.2. Okay. What is the compression of the spring? Huh? This one like no need to calculate. Okay, no need to calculate. Why? This one how long? 250. Then mm. This one how long? 200. How much is the compression? The compression is is 250 minus 200. So it is equivalent to 50 mm. 50 mm, I want to change it to cm. Alright, I divide by 10. I want to change it to meter, I divide by 100. So this is my answer. So it is 0.05. 0.05 meter. This one just convert the unit only. So answer is A. Right, you don't need to calculate. Just they ask you how much is compression. Okay. Now, diagram 18 shows a two steel spring with different diameter. Both springs are subjected to the same 10 Newton load, and then it is observed the extension of the spring A is more than B. A is more than B. Mean A extend more, B extend less. Why extend more? Less stiff. Alright, this is more stiff. Spring constant A is higher, yeah? No. Less K. Right, this is wrong. Spring constant A has A is higher. Spring constant A is higher. Spring constant A is higher. Huh? Aduh, you see, pemalas spring B lebih tinggi, but the type A is higher. So I change it. This one is supposed to be B. If not, cannot do. This one is B. You follow the BM one because they sometimes they got a typo. E, I put here. The spring constant is higher, more stiff. Yes, correct. Answer is A. Because I'm not sure whether they are typo or not, so we read 3 and 4. The elastic potential B, it is smaller. This K is higher. No. You didn't hang anything, then you cannot. So we see the answer. Right, 2024 Pahang. Pahang. Schema 1. 22. Number 22. 22 answer is A. Yeah, correct. They are typo. Typing error. Okay, typing error. This one should be B. Luckily, I read. If not, I'll say no answer. Okay. Next one. Diagram 19 shows a cat hanging on 4 identical springs arranged in parallel. So, which one is correct about the spring? The tension F plus 2. The extension of the string is 2 times. The extension is 2x plus 2x. The extension of the string is Excuse me. Okay, let's see. If I hang it this way, one spring, the extension is X, huh? Two string together, so the extension will be half of the X. Now this one is series again, parallel again, so this is half of the X. So altogether should be X. Diagram shows the cat is hanging on 4 identical springs arranged in parallel. Okay. The tension, nothing to do with tension. The extension of the string is 2x. No. The extension is 2x plus 2x. No. The extension is half x plus half x. Don't tell me the answer is D. Huh? This one no answer leh. The answer should be half x plus half x. It is x. We see Pahang. Pahang set 2. Set 1. Paper 1. E. Pahang set 2, paper 1. Pahang set 2, paper 1. No. Set 2 schema. Set 2 schema. This one should be paper 1. Uh, 23. 23. 23 is D, yeah. 23 is D. Don't tell me the answer is D. The answer really D. So I need to tell you here. So because of this one is 2 spring in parallel, so the extension will be lesser. So the extension will be half of the x. X over 2. So here will be another x over 2. Here will be another x over 2. Here x over 2, here x over 2. So total extension it is 1x. It is not x over 2. No. I don't agree. So I'll use my answer. Answer is the extension of the system of spring is x. X over 2 plus x over 2. Alright, my answer. Use my answer. Diagram 15 shows a girl play a horse spring at the playground. What is a modification can be done to the spring when a heavier kids play at the horse spring? So heavier mean, so you need this one to be your load it is higher. So F is kx. So the F is increased. So now you need to increase the K so that the X will be remain. Okay, you want to remain the X, huh? So the K have to be higher. K higher, so you got 4 factor, right? So 4 factor, one is use a shorter spring. Longer the spring, the X is higher, right? The X is extend more. It will extend more. So you want the K higher, so it will extend less, right? So you use longer wire, cannot, have to be shorter wire. Shorter wire, here don't have. You use reduce the diameter of the spring. Yes, this one will increase the stiffness, right? You will increase the K. Yeah. So increase the diameter of the spring. Diameter of the wire, not diameter of string. Diameter of wire, correct also. Increase the length, wrong. Use a high spring constant, yes. What should be done to the spring when the heavier kids play the horse? Increase the length of the string. So it is. Huh? I don't get it. Reduce the spring, the diameter of the string. Reduce the diameter. Reduce the diameter of the string. The K will be increased. Increase the diameter of the wire. The K will be increased. So increase the length of the string. The K will be decreased. Use a higher spring constant mean K is increased. So maybe they want the K to decrease. K to decrease, then what happened is the heavier lot sit on the horse. So the extension, the X will be a lot. Maybe they want a lot. So answer is C. I guess answer is C. Because this 3 is increased K. Only one it is make the K lower. So we see the answer, Police 2024. Police no answer. Police no answer. Wait 24. Yeah, no answer. No answer. Yeah, no answer. So the only answer that can be is C. C. Okay. We continue from here. A, B, C, D. Which one shows a large force requires the extension of the spring? Which one shows that the large force is required for the extension of the string? So I mean you need a lot of force then extend the spring. So the stiffness have to be higher. Higher gradient. Answer is A. Stiffness highest. So this one is stiff. This one second stiff. This one third. This one fourth. So answer is A. If you don't understand, alright, I use another way to explain to you. Like this one 10 Newton extend 4 cm. Let's say 4 cm lah, 10 Newton. This one 10 Newton extend 6 cm. So which one is more stiff? A is more stiff. Large force, you need a lot of force extend the spring. So this one 10 extend little only. So if you want the same extension, alright, 6. So this one probably need this graph probably need like 20 Newton. So you need large force. Alright. Okay. Next one. Which graph is correct? Diagram shows a two spring that is different original length. 19.2 shows the wood is moved toward the wall by F so that the both strings are compressed until T. Right? So the long spring, so this one is less stiff, right? So less stiff, the gradient it is less. So at first you press, it is easy. But two spring together, it is harder, right? So the gradient will be increased later. So originally, this one, so the gradient increased, yeah, correct. The gradient cannot be the same. The gradient cannot be decreased. No, this one is wrong. Answer is A. Answer is A. So here meaning that here it is two spring two spring together, here will be higher spring constant. Here will be one spring only. When you press here, this spring it is too short, so you press one spring only. So this one is not that stiff. So when you press two springs, so it will be stiffer. Okay. Still got a lot of question, never mind. I give you as homework 129. A lot. You try lah. A lot, really a lot. I told you, you do my exercise will be enough already. So I don't require you to do all. So you try to do, see whether how much you can do lah. Alright. So next week I will go for discuss. I go to discuss some only. I'm not going to discuss all. If discuss all, I really cannot finish the syllabus by I mean on time. Really cannot. Next week I try to discuss more on the I mean the paper 2. Paper 2 I haven't do. So probably I spend 1 hour for the paper 2, and then I will go for, I try to go to chapter 2 already. I'll send the notes into the group letter, right, for chapter 2. Is that okay? Any question before I end the class? Here is a lot of question lah. You try to do lah. If you can, the objective, I try lah. I try. You do. You pass it up to me. I'll mark for you. Okay. Any other question before I end the class? If not, then I am going to stop here. I'll see you next week. All right. Bye bye. Good night. Bye bye. If you still don't understand, you can question me. I will answer you. All right. Bye bye.